organic origin. Both 1 and 2, that's the physical and the chemical weathering, were subgrouped into either residual soil or transported soil. We also spoke about the solids, water, air, that's the soil particles, we also call it as soil skeleton, the water which is in the pore, and air if it is partially saturated. So we have 3-phase diagram. Remember, in this 3-phase diagram, the usual convention is to report volumes on the left hand side of this diagram and the mass or the weights on the right hand side. You looked at a few simple relationships. The first one being water content, being the weight or the mass of water over the weight of solids. Remember, it's with respect to the dry weight, the dry mass. The second relationship was void ratio. Again, volume of voids to the volume of solids. Third one was porosity, volume of voids to the total volume. The next being degree of saturation. You had volume of water, the volume of voids. The last one was air content, which was 1 minus the degree of saturation. For today's class, we're going to continue with the relationship, and hopefully we'll probably do 1 or 2 problems. Okay. Let me first right click and see it's downloadable. Yes. You're free to download this this version of the copy, PDF copy. If you right click, you can download it onto your terminal. Okay, let's continue, please. We'll speak about the definition of unit weight. Remember, a unit weight for a material like soil, I like to always call soil as a SpongeBob SquarePants. You know, it's like a sponge with a lot of openings. If you're familiar with the cartoon which is on SpongeBob, the behavior is very similar. The voids give a unique version of having either a bulk unit weight, that's the first one, or the dry unit weight. Let's look at the bulk unit weight. The bulk unit weight is the total weight, meaning weight of solids plus the weight of water. I'll probably zoom in, make it slightly more clear. So bulk unit weight is weight of solids plus weight of water being in the numerator over the total volume. Total volume would be the volume of solids plus the volume of voids. Volume of voids being volume of water plus volume of air. Okay. The next one is the dry unit weight. In other words, in the previous expression, the numerator has no water. So it has a similar expression with WS, weight of solids with no water, but the denominator remains the same. That is the total volume of the soil. Dry unit weight is important in soil mechanics. In fact, the mechanical behavior of the soil is governed by the dry unit weight. I would say partially governed by the dry unit weight. If you look at this expression very carefully, if higher the dry unit weight, the numerator is greater. If the numerator is greater, you have more particles packed in the same volume. In other words, the having more particles would in fact give it a better denseness. The greater the denseness of the soil, the greater or I would say the enhanced are the mechanical properties of the soil. The dry unit weight is important. This leads to the third definition, which is saturated unit weight. In other words, all the voids, if in the previous expression, if they are filled with water. So you have the saturated weight in the numerator, meaning weight of solids plus the weight of water. Remember, all the voids are now filled with water, and the denominator is the volume, which stands the same, the volume of the solids plus the volume of the voids. Let's look at the last one, which in fact the submerged or buoyant unit weight. It comes into picture whenever you are below the groundwater table. So whenever you have a buoyancy force which acts on you, a buoyancy force will only come when you are in a situation such as below the groundwater table. So a submerged or the buoyant unit weight is usually written as gamma prime, and if you're happy with CGS unit, it will be written as rho prime. So gamma prime in this case equals gamma saturated, which came out from the previous expression over here, is saturated unit weight, assuming that all the voids in the soil are now filled with water because it's below the water table. So gamma saturated is there minus the gamma water, which is the unit weight of water. The general value is 9.8 kilonewton per meter cube. Okay, let's move to the next slide, please. The next slide gives a pretty important definition of specific gravity. Okay, so rather than jump to specific gravity at one go, I would like you to look at what is the unit weight of solids. Remember, this is not soil, this is solids. And let me come back to the the description which I gave to soil, which is similar to SpongeBob SquarePants. So you have gamma solids, meaning you're just looking at the soil skeleton and the volume of the soil skeleton. In other words, if I say unit weight of solids, it would be defined as, let me zoom in please, weight of solids over the volume of solids. So you're just looking at the soil skeleton. Okay. If I say weight of solids over volume of solids, this is in SI units is gamma solid. If I divide this gamma solid by G, it gives me a value in CGS unit. This CGS unit is also particle density. But we are more familiar with this value being the specific gravity. And remember, when we write specific gravity, the value of specific gravity is just the same as particle density. However, the units of specific gravity are not written, because we'll come to the definition of specific gravity in a while. Before that, I would like you to look at some of the values, and these values are typical values for how the various soil constituents have a value of saturated saturated density in this case, the dry density and the buoyant density. I'll just like you to concentrate on the first column. Okay, the other columns can in a sense be simply derived from the first column, having known the water content. Let's look at some typical numbers. Sands will typically have 1.9 megagram per meter cube, or just in terms of our SI unit, it's roughly about 18 and a half kilonewton per meter cube. That's the range, 18 and a half to something like 24, 23. That's the saturated unit weight. If you scroll down, TT soils, which are purely organic, are close to have a unit weight which is very much close to water. So you're not very far off from the water weight. And similarly, the organic soil would somewhere lie around 1.3 to 1.8 megagram per meter cube. This range, it's quite a handy tool to in fact look at if you are given a soil sample and asked to visualize what would be the approximate constituents, not only while looking but also looking at the saturated unit weight. You can at least distinguish between an organic soil and an inorganic soil. Let me move on to the next slide, please. We come to the definition of specific gravity. Specific gravity, remember, is a ratio. So in other words, it's a dimensionless quantity. It's a ratio of weight of given volume of solids. So the numerator is the weight or the weight of solids, and the denominator is the same weight of water which has the same volume of the solids. So if I want to put it in simple English, specific gravity, let me zoom in please, equals weight of solids in the numerator, and the denominator has the same weight of water which has the same volume of the solids. So in other words, denominator would have volume of solids which would be henceforth occupied by the water times the unit weight of water. If you find this slightly tricky to remember, I would suggest you look at the next one. Specific gravity is unit weight of solids over the unit weight of water. That's easy to remember. So gamma solids we've just seen, and unit weight of water is obvious, we have just discussed. Let's look at some of the typical values of the specific gravity. If you look at the numbers vary by around 2.65. They actually move around 2.65 to about 2.7, may have a slightly higher value, but the numbers are very close. In fact, you would find the soils of any soils on this planet to have a similar number. Reason being, all the soils have major constituent of all the soils is silica, and the silica, because the silica is a fixed quantity, you have the unit weight governed by the unit weight of silica element. So in other words, you have something like a sand, clean sand, which is around 2.65, 68. So you have finer particles going down, which is perhaps clays, have 2.7 to 8. Silica is slightly, apologize, mica is slightly less. So you have, mica, if it has iron, it would have slightly 2.75 to 2.85. Organic soils would have less of specific gravity, which would be around less, of course, less than 2. We go to next slide, please. It leads us to some important relationships. In fact, these relationships are pretty important, and I would like you to take a piece of paper and jot down the final expression which we would derive in the next 2 or 3 slides. Please look at these, please jot down. Okay, I might pause. Somebody else is taking care of this, right? Okay, the first relationship is between the weight of solids, that's WS, the total weight, that's capital W, and the water content, small w. So we are aware total weight would be the weight of solids plus the weight of water. There's no rocket science on this. Weight of solids plus weight of water. Okay. If I take weight of solids common from the right hand side of this equation, I have weight of solids bracket 1 plus weight of water divided by weight of solids. Okay. If you look at this bracket very carefully, weight of water over weight of solids is in fact your water content. So I have total weight equals weight of solids times 1 plus water content. Or I can rewrite this expression as weight of solids, which is here, equals the total weight divided by 1 plus water content. Okay, that's the first expression, which I would say, I wouldn't ask you to derive this, but in a sense it's not difficult to remember. But if you find it tricky in the first few instances, it's easy to take them as a tablet. And believe me, the more problems you solve, it becomes much easier to remember all the expressions followed by this particular one. The second expression is very similar to the first one. The first one, remember, we had just the weight of soil and the solids. The second one has a denominator which is volume. So the weight by volume, which gives me the bulk unit weight. The bulk unit weight is now, the numerator is weight of solids plus the weight of water. Denominator is total volume. I'm not going to touch the denominator in this expression. Let's again take the weight of solids common from the numerator as we did in the previous expression. So the numerator has weight of solids times 1 plus weight of water over weight of solids. This particular expression is exactly the same as derived previously, so it has 1 plus water content. In other words, if I scroll, I have bulk unit weight is equals dry unit weight times 1 plus water content. I can play around with these terms to get dry unit weight, which is here, equals bulk unit weight, which is there, divided by 1 plus water content. Okay? That's the second relationship. The third one is in fact the relationship between porosity, that's N, and void ratio, which is E. Let's look at the definition of porosity N. N was defined as N equals volume of voids over total volume. What's the total volume? Total volume is the volume of solids plus the volume of voids. Okay. So if I look at the numerator and the denominator carefully, I have volume of solids over here. If I divide numerator denominator by volume of solids, I get volume of voids divided by volume of solids, which is here. Then the denominator equals 1 plus volume of voids divided by volume of solids, which is here. Okay. Look at this carefully. Volume of voids over volume of solids is your void ratio. Okay, remember the definition of void ratio, volume of voids to the volume of solids. I have void ratio here as well. So in other words, porosity equals to void ratio divided by 1 plus void ratio. I can play around with these terms such that my void ratio is on the left hand side. So I have an alternate expression. Void ratio equals to porosity over 1 minus N. That's 1 minus porosity. You can choose any expression, any one of these two expressions to remember. I hope you are making a note of the final expression, which is something like this. Okay, please do make a note. Okay, I apologize for this grid thing over here. Okay, it should not be grid, but you're looking at an alternate way to solve or derive this expression over here, which is there. An alternate way is to do it using phase diagram. Remember, all the subsequent derivations can also be done using phase diagram. So we're giving an introduction to this procedure as well. Also remember, the left hand side are the volumes, right hand side are the mass. So the first step is, let's assume or take the volume of solids to be 1. That's unity for us. What about the volume of voids, which is these two blocks, the Lego blocks which are over here? The volume of voids would be equal to the void ratio E. By virtue of definition, void ratio E equals to volume of voids over volume of solids. That's volume of voids over volume of solids. And volume of solids has been taken to be 1. So in other words, volume of voids is void ratio E. Okay. Let's pause over here and look at an expression which is total volume. Total volume equals volume of voids plus the volume of solids. Okay. I apologize if you're not able to see the suffix over here, but that's volume of voids plus volume of solids. Volume of voids in the previous step you have just looked at equals void ratio. And volume of solids, we started with 1. We took it as unity. So in other words, total volume equals void ratio plus, that's a plus please, 1. So I have the porosity, the definition of porosity is volume of voids over total volume. Volume of voids we have just seen is void ratio. and the total volume equals 1 plus void ratio. So it leads to the same expression as the one over here. And you're free to, in fact, if you like solving this problem using phase diagram, you're welcome to use this particular procedure. Let's move on to the next slide, please. The next slide leads to another alternate or another important derivation, which is between expression between void ratio E, water content small w, specific gravity Gs, and the degree of saturation S. So by virtue of definition, we know void ratio equals volume of voids to the volume of solids. Okay. If I multiply and divide the numerator and denominator by volume of water, I would get the same expression, but now there is a volume of water in the numerator and the volume of water in the denominator. That's over here. Okay. Let's look at this very carefully. Volume of voids to the volume of water. I'm not going to touch this, so it's over here. It's still there. Let's look at the second part, which is volume of water to the volume of solids. Now the volume can be related to weight and the unit weight by this expression. Remember, similar, density equals mass upon volume. So if this is volume, so rather than density we use unit weight, and rather than mass I have weight. So volume of water is replaced by weight of water divided by unit weight of water. Okay, straightforward. Similarly, volume of solids, if I use a similar expression, volume of solids should be related to the unit weight and weight, or in other words, density equals mass over volume. So volume should be density over, density equals mass over volume. So volume should be mass over density. Similarly, I have volume of solids, and rather than use density, I have unit weight. So I have volume of solids equals weight of solids over the unit weight of solids. Okay. Let's simplify this. The first one still remains there. That's over there. The second one, weight of water over weight of solids. I'll collect the terms over here. The third one, unit weight of solid will go up, unit weight of water will come down. That's over there. Okay. So in other words, I have void ratio equal to this whole lot. Okay, void ratio equal to this whole lot. Let's look at the first one. If you look at this carefully, volume of water over volume of voids is degree of saturation. So in other words, the first one is 1 over degree of saturation. The second one is weight of water over weight of solids, which is water content. The third one gives an important definition for specific gravity, which is unit weight of solids. Remember, this is solids, the soil skeleton, over the unit weight of water, which is our specific gravity. So I have an expression, a wonderful expression, SE equals to WGS. Okay, and this is an important expression which, in today's world, I would say all engineers, civil engineers, and geotechnical engineers in particular should in fact take this as a tablet on a first instant. If you can't feel like solving for it, you've got to remember, take it as a tablet. So SE equals to WGS. I can alternatively derive the same expression using phase diagram, and I'll do it again just so that it becomes an easy, handy tool for those of you who would be more comfortable to work with phase diagram. So the first one is the phase diagram. The first one is on the left hand side. I take the volume of solids to be 1. So the first assumption is similar to what we did on the previous slide. Volume of solids is 1, which leads to the volume of voids to be E, okay, by virtue of definition of void ratio. volume of voids is E. So I have volume of solids 1 and void ratio which is equals to volume of voids. Let's look at the definition of degree of saturation, which was volume of water over the volume of voids. Okay, look at this carefully please. Volume of water, okay, equals S times volume of voids I have replaced by void ratio. So volume of water equals SE. Okay. The next one is to carefully look at the weight of water and the weight of solids. Remember in the previous case we replaced weight by volume and we used the relationship between weight, volume and unit weight. So we're going to use this again. Weight of water equals volume of water times the unit weight of water. Similarly, weight of solids was volume of solids times the unit weight of solids. Remember the second expression is not soil, not the soil mass as a whole. So it only has the soil particles. I repeat, okay, it only has the soil particles. So look at the first one please. Volume of water over times the unit weight of water. So volume of water, I quickly club this expression over here which we derived equals SE. So I have SE, weight of water equals SE times the unit weight of water. Similarly, weight of solids was volume of solids. So I have replaced volume of solids to be 1. By virtue we took this as 1 times unit weight of solid. We use an important definition of specific gravity which is GS. So unit weight of solid should be GS times the unit weight of water. Okay. If I take a ratio of weight of water to the weight of solids, which is weight of water, weight of solids, it gives me water content. So in other words, water content should be equal to, the numerator is this whole fellow over here, the denominator is this whole fellow over here. If you take the numerator and denominator, suppose unit weight of water will get cancelled out. So you have a wonderful expression which is SE equals WGS. Okay. So again, you are free to choose any one of these two procedures to solve at home. Let's move to the next slide please. Okay. I believe this is the most important expression, and please concentrate. I hope you still have your paper and pen out. It's the relationship between the bulk unit weight, that's gamma B, gamma suffix B, specific gravity GS, void ratio E, and the water content W. Okay. Let's recall the definition of bulk unit weight. Bulk unit weight was total weight over total volume. Total weight was weight of solids plus weight of water, and the volume was volume of solids plus the volume of voids. Okay, straightforward. There's no rocket science in this, please. And from the numerator, I take W as weight of solid outside, so I have weight of solids times 1 plus the weight of water over the weight of solids, that's inside. From the denominator, I take volume of solids outside common, so I have volume of solids times 1 plus volume of voids over volume of solids. Okay, let's look at this expression very carefully. So I have bulk unit weight equals weight of solids over volume of solids. Okay, this expression should be equal to unit weight of solids, just the unit weight of soil skeleton, times 1 plus weight of water over weight of solids. It should be equal to water content, correct? And the denominator is 1 plus volume of voids to the volume of solids should be equal to your void ratio. Okay, so in other words, simplify this, bulk unit weight equals unit weight of solids, which is here. Numerator gives me 1 plus water content, which is here W. Denominator is 1 plus void ratio, which is here. Now from the previous slide, we have derived a wonderful expression which is SE equals WGS, and I hope it's still on your paper. So from there, can I just replace W by SE by GS? I've done this. W equals SE by GS, that's inside, and the weight of and the unit weight of solids is replaced by unit weight of water specific gravity. That's over there. Okay. Let's solve this and simplify this. I have GS over here, so I can multiply by GS and take GS plus SC divided by GS. Okay, so I have GS plus SC divided by GS. These two terms come over here. Term is there. So in other words, GS gets cancelled out, which leads to an expression bulk unit weight or gamma B equals GS plus SC divided by 1 plus C times gamma W. Okay, again this is an important expression, and I'm sure with time, with practice on column sheets, this expression will be on your tips of your finger. A kind of, it becomes more of a song kind of thing. GS plus SC over 1 plus C times gamma W. Please do remember this, it's important. In fact, for any level of soil mechanics or geotechnical engineering, such expressions would be used. Okay. Now, in the next slide is in fact some variation of this bulk unit weight. This box is not clear, I apologize. It's gamma bulk equals GS plus SC over 1 plus C times gamma W. It's the same expression which we have derived. We're going to look at some cases. Okay, some cases of this expression very quickly here. What happens? Degree of saturation is 1, meaning if your soil is saturated. If your soil is saturated, S becomes 1. Remember, the range of S is between 0 and 1. So the maximum value of S is 1, which leads to gamma bulk equals gamma water times GS plus E over 1 plus E. That's over here. In fact, I do not need to remember the saturated unit weight, the expression for saturated unit weight, as long as I only remember the bulk, because S equals 1 over here. For dry unit weight, what happens if I'm looking at dry soil? So instead of gamma bulk, I have gamma dry over here. Inside this bracket, S becomes 0. So this whole term disappears. So I get GS times gamma W over 1 plus E. Similarly, the submerged unit weight is gamma prime. Remember buoyancy. Because of buoyancy, the net weight gets reduced. So gamma prime equals to gamma saturated minus gamma W. Gamma saturated, I just plug it from this expression. In fact, I don't need to remember. Minus gamma W, which is over here. And very quickly, if you solve for this, gamma prime should be equal to this whole lot. GS minus 1 times gamma W over 1 plus C. Again, I do not suggest that you remember this. Don't remember any of these expressions as long as you know what is the bulk unit weight. Okay. I'm going to move to the next slide, which is a problem sheet. Okay. Before we do that, do we have any questions, please? Okay. Can we load the second document? Yes. Any questions, please? What's this? Okay, thank you. KNMU, we are with you.
इधर आ जाओ. Hello. Hello.
Yes, we can hear you.
Good morning, sir.
Good morning.
Sir, my question is that Hello.
Yes, continue with your question.
So my question is that I didn't understand the void ratio between the coarse grain and fine grain particles.
Void ratio, apologize.
So my question is that the void ratio of coarse grain particle is smaller than the fine grain particle. How it is, sir? I didn't understand.
Okay, that perhaps leads to the previous lecture, if I'm not wrong.
Yes,
Right?
sir.
Uh, we use a piece of paper to explain this. Okay? No, wait. I think I can.
What is it? Hello?
We have a term void ratio equals to volume of voids over volume of solids. Okay? Now, if I repeat your question is void ratio for clay is greater than void ratio for sand. Is that your question?
The question is
Now,
that the
please look at the definition of void ratio. I have volume of voids over volume of solids. Let's look at sands very carefully. In sands, you have a soil particle which is bigger than the particle of the clay.
fine.
So I have volume of solids, the denominator, which is large.
Yes, sir, its volume is same.
Sorry?
If the volume both the particles are same,
Then you look at if particles are same, then you would look at volume of voids. If the volume of voids are also the same, then you have E clay be equal to E sand. And you can have a situation where both the void ratios are same.
so can you prove this?
Prove this.
Yes.
Now, what if you have a clay, your clay can also have the same void ratio of sand. I have a sand which is void ratio of 0.7. Clay can also have 0.7. It's possible. Whereas the usual clay, E for clay can approximately be maybe 1.7 or 1. Perhaps 1.2. E for sand perhaps 0.7 or maybe 8. Just throwing in some numbers. So this void ratio has nothing to do with individual volume. Remember, it's a ratio of the two. So you can't take it into individual volume. The clay particles are pretty small. Okay, compare this to the volume of solids is small over there, which makes my ratio larger. If I have denominator which is small, the E value will on its own become large.
So वीडियो हटाना वहाँ से सर साउंड नहीं आ रहा साउंड क्लियर नहीं आ रहा सर वो वीडियो ऊपर करना वहाँ से सर वो वीडियो ऊपर करना वहाँ से
Was this your question?
Yes, sir. Hello, yes, sir.
Okay. Was I able to satisfy your question?
Sir, no.
Okay, I'll leave you for a while. Think about it. I'll come back to you again if needed.
Thank you, sir.
Okay, VCE teacher, we are with you, please.
Sir, you are given soil classification based on the specific gravity. So here actually you are given the ranges like clean sands 2.65 to 2.68. If I get the specific gravity 2.67, so will I consider which type soil I have to consider, sir? Will I consider the clean sand or silty sand? Because 2.67 there are two ranges.
Yeah, okay. I would not recommend that based on specific gravity you start classifying or looking at what are the soil particles. Usually both sands, clay, even gravel to some extent, if not given, we take a specific gravity value of 2.65. It's like a unique number. So please do not use your soil description based on specific gravity alone.
Okay.
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 So that table which was given was just a table to show you a range. The range was, in fact, if you look at the range carefully, it just fluctuated between 2.65 to perhaps 2.75, and you could you're free to if not given any value, you're free to choose a value something in between. But if you get a value something like 2.2,
no,
yes.
if 2.67 is given, so will I consider which type of soil, sir?
No.
2.67.
Yeah.
Will I go?
That's precisely my question. Please do not describe the soil or look at the soil based on the value. Okay, the value can be
Okay.
the same. Value can be the same. Okay. Okay. Thank
Okay.
you.
Thank you.
Okay. So no more questions. We've given. Let's look at the document. Okay. We have listed down. This problem sheet 1 based on your interaction between the previous lecture and today's lecture, and I'll just right click and allow download. So in other words, you're free to download this problem sheet at home. These 4 questions are not exhaustive, so I'll just zoom out to show you. The 4 questions are not exhaustive. If you pick up any book on soil mechanics, and please look at the section on problems or solved examples. My suggestion is do not go through the solution, because each and every to achieve the same answer, there are more than one way to achieve the same answer. So my suggestion is you just look at the question and try to solve on your own. Having given jotted down the really which you have probably jotted down on your piece of paper during this course of this program, as I had suggested. If you have jotted down the formulae, you can easily solve all these 4, not only the 4, but any problem given to you. We have approximately 10 minutes, and in these 10 minutes maybe we can do 1 or 2 problems. I'll try to do 1 or 2 problems today, but let you live in peace for the remaining 2. But before we come back for the next class, I request that you please do a hands-on session on your own. Okay? Let's look at question number 1, please. It's the simplest of all. I think it didn't go through while I prepare this. Use this. After this, there's another class. started 10 minutes late. The previous class ended 10 minutes late. So I get a chance to extend 10 minutes? No. Okay, the first question. It says that there is the volume of the soil is given. Remember, I'm going to just sketch the answer quickly. The total volume of the soil is given as 1 meter cube. The total weight of the soil is given as 20 kilonewton. Remember, this weight should include weight of solids plus the weight of water. Okay, and this volume should include volume of solids plus the volume of voids. Okay, specific gravity GS is given as 2.67. Okay, the first part of the question, determine the water content. Okay, the easiest, water content by definition equals to weight of water over the weight of solids. Now, you look at this carefully. Dry weight is given. So weight solids is given as 18 kilonewton. That's the dry weight. So I have weight of water, which is 20 total weight, minus the weight of solids. So the difference gives me the weight of water, which is 2, over the weight of solids, which is 18. Okay, if you solve by 18, I think you get a number like 0.111, or in percent it's 11.1%. Let's look at the second one, which is again quite easy. Okay, porosity. Okay, porosity is defined, N is defined as volume of voids over total volume. Okay, so total volume is given to us 1 meter cube. What about volume of voids? Okay, if you recall, let's look at the definition of GS, specific gravity. GS is defined as unit weight of solids over unit weight of water. Okay, unit weight of solids is weight of water over weight of volume of solids, apologize, times the unit weight of water. Okay, again I repeat, the objective is to obtain volume of voids. Total volume is given to us. So if I am able to evaluate what is my volume of solids, I can evaluate what is volume of voids. Okay, so the idea is to obtain volume of solids, which is here in the denominator. In this expression, GS is given to us, weight of water is given to us, the unit weight of water is 9.81. So let's use this information. So volume of solids, which is here, equals to weight of water, okay, which is 2 divided by weight of water divided by specific gravity. Specific gravity is 2.67 times 9.8. Okay, which gives me a value of 0.688 meter cube. Okay, the volume of voids is derived. So can I say volume of solids equals total volume minus volume of voids? Gives me a value of 1 minus 0.688, or a value of 0.312 meter cube. Okay, VC teacher will just come back to you in a minute. Okay, come back to you in a minute. What about the next one? If volume of solids is known, what about volume of voids? Equals to volume of solids is total volume minus the volume of voids, which is here. So volume of voids equals to, I'm getting confused over here, sorry. A question objective was volume of voids over total volume. This gave me a volume of solids over here. That's volume of solids, and this is volume of voids, volume of solids. That's volume of voids for us. Okay, I was mixing up these two. So I plug in this volume of voids back in this expression. Our porosity equals to 0.312 divided by total volume, which is 1. That gives me 0.312 or 31.2%. Okay. Like I said, there's more than one way of doing it, and probably we are just using one of the methods. The next one in the same question is what is your void ratio? Void ratio, again I can relate void ratio, use the expression between void ratio and porosity equals to n over 1 minus n. So the porosity which we have derived previously, I can just plug in, or I can also use volume of voids over volume of solids. Okay, the answer to this would be 0.453. The next one is your degree of saturation. S. Remember, S is defined by volume of water over volume of voids. Okay, volume of water, okay, can be rewritten. Okay, remember we just looking at one of rewritten as weight of water over unit weight of water. Okay, and volume of voids we have just derived. Can I rewrite this as weight of water is 2, unit weight of water is 9.81 times the volume of voids, which I think we have derived as 0.312. So this leads to a value of 0.654 or 65.4%. The next part is to draw the phase diagram, and okay, let me show you the phase diagram, please. Okay. On the left hand side you have the volumes which you just solved. Right hand side are the mass or the weight, which most of the data appears to be given. Okay. Now you have your, like I said, you have 3 more questions, and again I request that you please go home and try. If you have any doubt, next time we'll continue with these questions with the other 3. If you have any additional question which you feel you like to solve, please email them to me. My email address, I repeat, I'm not sure if it's available with you. It's AJUNEJA, it's one word, at iitb.ac.in. Okay, please be free to email anytime. Before we conclude, okay, we have one question from VCE teacher. I'm just going to start interaction, please.
Hello.
Yes, we can't see you, but we can hear you. Yes, please.
Good afternoon, sir.
Good afternoon.
Yeah, sir. Actually, in the problem you gave it specific gravity is unit weight of solids by the unit weight of water.
Hmm. Yes.
And that unit weight of solids is weight of solids by the volume of the solids, right?
Yes.
But in the solving the problem, you wrote that is weight of water by the volume of solids. Can you check once?
Yeah, weight of. Yeah, this is unit weight of solid. I'll just redo it. Specific gravity.
First problem. The second is writing that one. unit weight of solids, you wrote it as a weight of water by the volume of solids.
Yes. Specific gravity is unit weight of solids over unit weight of
Solids
water.
by,
Unit weight
and
of what?
solids is weight of solids by
Weight of solids over volume of solids into
volume
unit weight
of
of water.
solids into,
Unit
yeah,
weight of
but that
water.
is not with your question.
Okay, I apologize if it has been a mistake in writing, but specific gravity is always, as you correctly say, weight of solids over the volume of solids
To
and
volume of
the unit weight
solids.
of water. So weight of solids is 18. I think a mistake, 18 over volume of solids, which is unknown, times 9.8 equals to 2.67. I think this is the number.
Yes, sir. That's
Thank you.
okay. Okay, sir. Thank you, sir.
Okay. If you want, you can do just one simple one. 5 minutes. No? Okay, we'll stop over here. Before I stop, there is one small, based on previous lecture, there was some suggestion on to add, right? Document. There was, can you open up a document? There was suggestion to slightly modify the course content. I think this one. So the course content, this morning I sat down and took a serious look at the topics which, suggestions came in to add a few topics. The topics which were added are consolidation, okay, consolidation, effective stress, permeability, and shear strength. Somewhere here shear strength. And I think someone suggested on slopes as well. So within the first 15 lectures, in fact, I have added the the maximum possible content for the entire the geotechnical analysis which was possible. Because of this, some minor topics had to be removed. So I suppose the topics such as soil classification has been removed. There have been other minor removal as well. So my request is to, again, I right click and allow download. My request is to please go through this sheet, download this sheet, and please go through it and see if you're happy with it and you're comfortable with this modification. Okay, thank you and goodbye.